Good afternoon, everyone. Thank you for joining us today. Math is Tutors, we're free live math tutoring session. I hope you're going to have a good time. I'm looking forward to a good time with you all. Thank you for all who have joined. Please feel free to share this, subscribe to our channel so that you can get notified when we have any updates or any notifications that you need to know of. Please go ahead and subscribe, share with your friends, and I look forward to the hour with you all. And let's get started. Good afternoon, Semi. Good afternoon, Ini. Thank you for joining us today. Looking forward to having a great time with you all. So we're going to have, today's Tuesday, so we're going to focus on second graders all the way through 7th grade. If you're in 6th grade and you're in pre-AP, this also will be good for you. 7th grade regular math, this also is going to be helpful to you. If you have any questions along the way, please feel free to ask. Don't shy away from asking. And if there are any topics that you want me to cover during the session, please let me know as well. I'll be glad to put on hold some of the things that I've already planned and actually address the questions that will benefit you right now. I want to make sure that as you're in school, that I can help address questions that you may have based on what you're learning in school right now, so you can end the semester strong. All right, thank you all for those who are just arriving. Thanks for joining. Thanks for joining. We're gonna have some questions. The way I like to do mine, which is different from most people, is I like to put up the question. I give you a chance to try it out, and maybe I'll give you a minute or two, just depending on how difficult the question is, and then we'll go ahead and take a look at how we can do them together. If there are different approaches, I'll also show you the different ways to do the questions as well. So we get started. It's 1:02 right now, so let's wait for 1 or 2 more people, and then we'll get started. But I know you can see the grades and the topics that are being addressed for each of the questions, but I always welcome anyone to answer the questions, because even if you're in 6th grade, there may be some things in 3rd and 4th grade you may have forgotten. So this is also another chance for you to get a refresher on those topics. All right, we got our 2nd and 3rd graders. We're looking here at place value, and we're going to focus on estimating sums. Okay. Let's see. Are there any 2nd or 3rd graders joining us today? If you are, please just let me know that you are here so that I don't just go ahead without hearing from you. Okay, let's go ahead and start with this question here. So we have here, in an elementary school, there are 347 first graders and 573 second graders. Estimate the total number of first and second graders to the nearest 10. Okay, I see. Thank you, Jaden, for your answer. I see also Simi has responded, so thank you all for responding. Okay, let's go ahead and start with this question here. So we're looking at the total. So we're looking for keywords. Whenever you're dealing with word problems, go ahead and look for as many keywords as possible. We have the word total. So this just tells me that we're going to be adding numbers together. So we will need to we need to estimate the sum to the nearest 10. So what I like to do, I'm going to do 2 different things here. We have 347. We're going to first convert this to, we're going to first round this to the nearest 10. So to round to the nearest 10, you're going to focus on the digits in the tens place. So you have 4 here, and then we're going to look to the right hand side. You're going to see 7. 7 is greater than 5, so this is going to be 350. And then we have 573, and 7 is in the tens position. We're going to look to the right. We have a 3 there, so 3 is less than 5, so we get 570. And so we're going to add these numbers together. So 350 plus 570. So we're going to add these numbers. 0 plus 0, we have 0. 5 plus 7, we have 12. When you write 12, we're going to write 2 here and bring 1 up here. 1 plus 3, 4. 4 plus 5, we have 920. So this is a very common approach. The other approach you could use is, this is not as commonly used as the other one. So we have 7 plus 3, we have 10, 0, bring 1 up here. 1 plus 4, 5 plus 7, 12. And then we bring 1 up here. 1 plus 3, 4 plus 5, 9. So this just happens to be a perfect solution where you get to 920 regardless. But if you have this type of a problem in your assignment or homework or test, this is the better approach to use. Most of the questions will actually tell you to estimate each of the numbers first and then estimate the sum to the nearest 10, 100, or 1000. Okay, that's good. Thank you all for trying. Does anyone have any questions about the approach here or any other? You can also offer your own suggestions on how you approach your question. And if you do or have any questions along the way, please let me know, and then we'll go ahead and entertain your questions and suggestions. Okay, so now we have third graders and fourth graders. This is similar to something we did last week, but I tried to put a different twist to it this week. So we have a newlywed couple is remodeling their living room. A new rug will cost them $158. A new sofa will cost $597. A new center table will cost $187, and a new set of curtains will cost $97. If they have $956 to spend, can they afford to remodel their living room? If they cannot, let me know. If they can, also let us know your reasoning. So I want you all to try this. This is a real life type of question. I like to try to bring things in a way that you can relate to. So you have a couple, so people who two people who just got married, and they need to remodel the living room. So they're going to spend on a sofa, a new rug, a new center table, and a new set of curtains. But they have limited funds. The question here is, do you think they can afford this project to remodel their living room? So that's what we're trying to find out here. Yes, Simi, I think that's next on the set of questions we have. Converting from fractions to decimals, that's next. Okay. So I'll wait on a few responses before we go ahead and try to solve them together. Okay. I'll give you a few more seconds and then we'll go ahead and try this together. Don't forget my preferred approach to this is to draw a table. We're going to draw a table here, and in the table we're going to have a plus section here and a minus section, and the plus section is going to have the amount of money that the couple has, which is $956, and then the minus section is going to have the amount of money they have to spend or they're planning to spend. So we have 158 over here, 597 over here, 187, and then 97. So those are the amounts of money that they are that they want to spend to remodel. So what we're going to do here is to find out how much they have and how much they're planning to spend. So we already know what they have. This is what they have right here. So let's go ahead and find out how much they are planning to spend. So we have 158 plus 597, and then we have 187, and then we have 97, and we're going to put a 0 here just so we have 3 digits on each row. And so we add all the numbers starting from the right hand, the ones column, so the rightmost column. So we have 8 plus 7, which is 15. 15 plus 7, that's going to give you 22. Plus 7, you have 29. So we're going to write 9 down here and bring 2 up here. 2 plus 5, we have 7. 7 plus 9, we have 16. 16 plus 8, we have 24. 24 plus 9, we have 33. So we're going to write 3 down here and bring 3 up here. 3 plus 1, we have 4. 4 plus 5, we have 9. 9 plus 1, we have 10. So now what we have seen from this, okay, Simi, that's correct. They're over budget. Good, good. Thank you for that contribution. So we have 1,039 is the sum of all of this right here. So what you're seeing here is that they have $956 to spend, and they have $956 to spend, but after adding up all that they intend to spend, they have to spend $1,039. So this just tells you that they don't have enough money for what they're trying to buy. So the other question we could add to this is, how much more do they need so that they can afford all that they intend to buy? So when you get to that point, when you see how much more, we're looking at a situation like this: 1,039 minus 956. So let's go ahead and do the subtraction. 9 minus 6, we're going to have 3 here. And then 3 minus 5, we can't do that. We're going to come over here. We can't do anything here. So we come over here. We're left with 0. 10 here. Now, we can now borrow 1 from 10. And then we're left with 9. And then the one we borrow becomes 10. We add it to 3. It becomes 13. 13 minus 5 is going to be 8. So in other words, they need $83 more to be able to afford the renovation. Does that make sense to everyone? 3rd and 4th graders. So these are the different ways this question can be asked in a test or an exam. I just wanted to show you the thought process and then also extend the question a bit further so that you can see the different places we can go with this question. All right, so I know that Simi is asking for converting fractions to decimals. So I have some questions on that here. So we have these 2 fractions and we want to convert them to decimals. I want you all to make an attempt at these questions, and let's see how far we can go. And then once you're done with that, I'll go ahead and show you what to do. Or if you're not sure how to do it at all, Simi, if you're not even sure what to do, just signal and then we'll go ahead and proceed, because this question is from you. Okay, let's give you a few more seconds to try this out and then we'll proceed. But if you're not sure what to do, also signify and then we'll just go ahead and get going with these questions. Okay, so let's go ahead and proceed with these questions. Looks like Simi, looks like you need some help. So here's what we're going to do. You have to first realize when you have a fraction, we're going to use the long division method right here. And this right here, you have to figure out what location you have to find out what this number represents and what this number represents. So when you're dealing with long division or you're dealing with division, you have three things. You have your quotient, you have your divisor, and you have your dividend. Okay, so your divisor is always your denominator. This is your denominator. Your dividend is always your numerator. Okay, so now we're going to go ahead and in long division, generally, what you have here is your dividend, and then this is your divisor, and then right here is your quotient. Okay, so what you're going to have here is you have your 3 here, so your numerator goes inside, your denominator comes outside. So that's how you would start this. Now, the question you're going to ask yourself is, how many groups of 8 can you find in 3? We know that 3 is less than 8, so you can't have any group of 8 in 3. So we're going to put a 0, and then we're going to put a decimal point right here. Putting this decimal point right here allows you to introduce a 0 here inside of your division sign. So now it becomes 30. Now you're going to ask yourself, how many groups of 8 can you find in 30? Now you're going to have 3 groups of 8 in 30. 3 multiplied by 8, you have 24. And then we subtract. When you subtract this, you're going to end up with 6. Now, how many groups of 8 can you find in 6? No, we can't. But look, we have this decimal already. So because of that, I have the right to bring a 0 in here. And then you now have 60 divided by 8. How many groups of 8 in 60? We have 7. 7 multiplied by 8, we have 56. We subtract again, we have 4. 4 is less than 8, so we can just bring another 0, and that's what this decimal point allows you to do. Sorry. The decimal point allows you to continue to introduce zeros until you get a termination or until you want to stop. So how many groups of 8 in 40? We have 5. 5 multiplied by 8, we have 40. So this is 40 minus 40 is 0. So now 3 over 8 is now going to be the same as 3 over 8 is now the same as 0.375. Maybe in the next week I'll show you how to convert this back to a fraction. I'll see if that's something you want us to work on, and then we can focus on that next time. So now you have this approach here. Then let's go ahead and try the next question, just so you can. I know with math, sometimes you have to see something done a few times. That's why I put 2 questions here. So I'm going to now, we remember our numerator goes inside and our denominator goes outside. First question we need to ask is, how many groups of 20 do we find in 11? 11 is less than 20, so we have 0. And then because we have 0 here, we can introduce this decimal. This decimal allows us to actually introduce a 0 here. So how many groups of 20 are there in 110? If I multiply 20 by 5, I have 0 and I have 100. So I have, and then 20 multiplied by 6, I have 0 and I have 12, so 120. So I'm going to use 5. 5 multiplied by 20 is 100. And then we're going to subtract. We're left with a remainder of 10. Now that we have this decimal again, we can introduce another 0 here. 100 divided by 20, we have 5. 5 multiplied by 20, we have 100. And you subtract here, you get a 0. So therefore, 11 over 20 is equal to 0.55. Perfect, perfect. Good afternoon, Adedayo. Good to have you. Thank you for joining us. So this is how you deal with converting fractions to decimals. And these cases that I have here, I will call them, and I like to start with terminating decimals because, and all that simply means is that they can end. So you get to a point where you have a remainder of 0. That's what you call a terminating decimal. There's some that are non-terminating. They will continue forever. For as long as you have time, you can still continue building up these decimals. And so we may do that next week just so you get, but I want to start off with something that it's easier for you to understand, so we can build up from this. Now, okay, Adedayo, thank you. Thank you for joining. Simi, thanks for inviting your friend. So what I'm going to do here, I know this is not what I plan to do, but because this is a topic you're going through in school right now, I'm going to actually write a question that I want you to try. I want you to convert 3 over 4 to a decimal. So let's try this one, and then after this we'll go ahead and attempt the other questions that we have. So we want to convert 3 over 4 to a decimal. Please do not use a calculator. Okay, that's fine. Do not use a calculator. I want you to go ahead and try to convert this, and then once you're done with that, we'll be able to do it together. I hope you understand the method I'm using so far. If you have any questions about this method, please let me know, and we'll use this as another opportunity to address your concerns. Okay, I'll wait for a few more moments, and then we'll go ahead and attempt this as a group. Let's see. Thank you for who's joining. Someone just joined. Thank you for joining. Please feel free to ask your questions, and also subscribe to the channel, share with your friends. Let them know there's some place they can come ask questions and feel safe. Okay, that is good. That is good. Okay, that's a good attempt. So let's go ahead and do it together. I think you are on the right path. So we have 3 over 4. We have our 3 inside here and the 4 on the outside. How many groups of 4 in 3? 3 is less than 4, so we have 0. And then we're going to put a decimal point here, which allows us to make this 30. How many groups of 4 in 30? We have 7. 7 multiplied by 4, we have 28, or 28. So we subtract, and we're left with 2. How many groups of 4 in 2? We have 0, so we're going to introduce a 0 here, all because we have this decimal. 20 divided by 4, we have 5. 5 multiplied by 4, we have 20. We subtract, and we're left with 0. So that means that 3 over 4 is equal to a terminating decimal of 0.75. So good job. Good job. Good try, Jaden. So Simi, that's good. So I'm happy that you're able to get the answer to this question. And so let's go ahead to the next question. So if you're in any of our 2nd to 7th grades and you have questions that it's relevant to what you're doing in school right now, feel free to ask. I'll go ahead and put something else on the back burner for next time and address your question. Okay, so we have our 2nd to 3rd graders again. We have a money word problem. And so here we're looking at Ryan receiving an allowance of $102.50 from his parents. He spends $69.87 at the video game store and $24.45 at the grocery store. If he saves the rest, how much money does he save? Oh, you're welcome, Simi. You're welcome. So if he saves the rest of the money, how much is he actually saving? Always feel free to use the table method. The table, you have one side is positive, which is the money you get. The other side is minus the money you spend. And then you can use that to easily help you get to the answer to this question. Okay. All right, I'll wait for a few more moments and then we'll go ahead and take a crack at this. I have some fraction problem. I think it's coming up soon, and just because I told this group that every time we meet we're going to do some fractions. I always have an addition or subtraction and a multiplication or division problem. Okay, so let's go ahead and attempt this question together. I'm going to draw my table. I got my plus and my minus. Plus here, minus. Plus is the money that Ryan is going to receive. So Ryan receives an allowance. So that is $102.50. And here's how much he's spending: $69.87 at the video game store and $24.45 at the grocery store, most likely buying candy. And so we have $69.87. We have $24.45. We're going to add this together so we can know how much Ryan has spent. So 7 plus 5, we have 12. We're going to write 2 and bring 1 up here. 1 plus 8 is 9. 9 plus 4 is 13. We're going to write 3 here and bring 1 up here. 1 plus 9 is 10. 10 plus 4 is 14. Let's remember our decimal here. So it's 14. We're going to write 4, bring 1 up here. So we have 1 plus 6, 7 plus 2. We have 9. So now we're going to subtract because we want to find out how much is left. Because here is how much, this is how much Ryan received, and this is how much Ryan spent. So now we have $102.50, and we're going to subtract $94.32. I'm going to put a 0 here just so we have the same number of digits all up and down, or top and bottom. So 0 minus 2, we can take 2 from 0, so we're going to come to 5 and borrow 1. We have 4 left. Okay, thank you, Jaden. That is good. So the 1 we borrow becomes 10. We add it to 0, and this becomes 10. 10 minus 2, we have 8. 4 minus 3, we have 1, and then we have our decimal here. 2 minus 4, we can't really do that. We're going to come over here. We can't really do that here, so we come over here. We borrow 1, so the 1 we borrow becomes 10. So now we can borrow 1 from 10, leaving us with 9, and the 1 we borrow becomes 10. Add it to 2, we have 12. 12 minus 4, we have 8. 9 minus 9, we have 0. 0 minus 0, we have 0. So therefore, Ryan has a balance of $8.18, which is how much he's going to save. Good job, Adedayo. Good job, Simi. Good job, Jaden. Thank you for attempting this. All right, so let's go ahead and let me see what we have next. We have our fractions. After this, I'm going to entertain a question from, I think we have time, so we'll keep going. So we have these fractions. We're going to add 2/3 and 3/4, and then we're going to multiply 2 1/3 by 9/14. So we have 2/3 and 3/4. I have another question that a student sent, so most likely after this, I'll address that question. Okay, I want you to go ahead and try to solve this fraction. Always remember, and I'll say this every single time just so you can remember, that whenever you are adding fractions, you have to make sure that your denominators are exactly the same. You cannot add fractions if the denominators are not the same. You cannot subtract fractions if the denominators are not the same. So make an effort to always make sure that your denominators are the same. So we have these fractions here. We're going to find a way to make each of them have the same denominator. All right. Let's give you a few more minutes. Maybe not minutes, but a few more seconds, and then we'll go ahead and proceed with this question. (17/12), correct. That is good. I want you to actually go ahead, take one extra step, Simi, and convert it to a mixed number. Just put a space between the whole number and the fraction, the proper fraction. Go ahead and do that. You're on the right path. Jaden, good also. Good. All right, so looks like we have a few responses. So let's go ahead and do this together. So we have 3 and 4 as our denominators. So we cannot use them in this form. We have to find a way to arrive at a common denominator. So 2/3, I'm going to just make 12 our denominator, 3 multiplied by 4. So I'm going to multiply 3 by 4, and then I'm going to multiply 2 by 4. This is going to give me 8/12. And then I have 3/4. I'm going to multiply 4 by 3, so I have to multiply 3 by 3. I have 9/12. So now I have 8/12 plus 9/12. Now that I have a common denominator, I can actually add my numerators together. So I have 8 plus 9/12, which is equal to 17/12. So we got that answer. All right, perfect. Anastasia, perfect. So Simi, I was saying that I want you to convert these 17/12 to a mixed number. Some may call it a mixed fraction, but that's what I'm intending for you to do. Okay, so we have 17/12. So we're going to go ahead and remember we did this earlier. Whenever you have a fraction, the numerator goes in here and the denominator comes outside. So 17 divided by 12, we have just one group of 12 in 17. 1 multiplied by 12, we have 12. We subtract, we're left with 5. So this is the same as 17 divided by 12 is one group of 12. We have a remainder of 5, and we're dividing by 12. So that is that. Okay, good. So now let's go ahead and walk through the multiplication. Whenever you're multiplying, make sure that your fractions are either they have to either be proper fractions or improper fractions. You cannot work directly with whole numbers, at least at your level. At your level, I wouldn't want you to do that. It will confuse you. So what I want you to do is go ahead and convert every mixed number to improper fraction, and then go ahead and walk through it. All right, let's get going. So I'll give you a few moments to try this out, and then I'll show you the best way to go about it. I hope so far your questions have been addressed. Are there any questions that you have that you would like for me to address? Please let me know, and I'll be glad to do that for you. Also, while you're at it, if you haven't subscribed to our channel, please go ahead and subscribe to the channel. Sometimes when I get questions from these sessions, I actually go create a video for it, just so that I can give it some more time and more emphasis that I could not have given it to it during the free live stream session. All right, so let's go ahead and do this together. We're going to first convert our mixed number to an improper fraction. So 2 1/3, this is going to be, we're going to multiply the whole number by the denominator. 2 multiplied by 3, we have 6, plus 1, we have 7/3. So now we have 7/3 multiplied by 9/14. So now we have two different ways to go about this. We can go ahead and multiply across. 7 multiplied by 9 divided by 3 multiplied by 14. This is going to give you 63/42, and then you can keep dividing. We can divide by 7, or we can divide by, let's go ahead and divide by 7. Let's divide by 7. We have 9/6, and then we can divide by 3, and then we have 3/2. So that is one way to do it. The other way to do it is 7 over 3 multiplied by 9 over 14. What we're going to now do is look for common denominators in the numerator and denominator. So we can see that 7 and 14 share common, they have a common factor rather. Sorry, not common denominator, common factor. The common factor here is 7. 7 divided by 7, I have 1. 14 divided by 7, I have 2. And then 3 divided by 3, I have 1. 9 divided by 3, I have 3. So now I can multiply 1 by 3, which is going to give me 3. I can multiply 1 by 2, it's going to give me 2. So now we can go ahead and convert this to a mixed number. So 3, 2. We have one group of 2 in 3. 1 multiplied by 2, we have 2. We subtract and we have a remainder of 1. So this is going to be 1 and then a remainder of 1 divided by 2, which is also the same as this. Okay, so what I want to do now is I'm going to address a 7th grade question. This came through as one of the questions to be addressed. A student asked this question, so we're going to go ahead and try that. Okay, we're trying to solve two-step equations. This is grade 6, and in some grade 6 or grade 7, this is a question that could be asked in any of those grades. So we have 5x equal to 3x plus 10. We want to find the value of x. What is the value of x if 5x equal to 3x plus 10? If 5x equal to 3x plus 10. So when it's called two-step equations because you have to do 2 things before you get to your answer. You have to do 2 things, take 2 steps to get to your answer. That's why it's called a two-step equation. Okay, I'll wait for a few seconds and then we'll go ahead and try and see if we can get some answers. And if we're not able to get answers, then I'll go ahead and show you what to do. Okay, so I'm not getting any responses yet. So let's go ahead and, for the benefit of everyone, I'll show you what to do here. So we have 5x equal to 3x plus 10. When you're dealing with equations, what you're trying to do when you're solving an equation is you're trying to isolate the variable. That's the terminology. So we're trying to isolate the variable. And all this simply means is that we want to make sure that the variable stays by itself alone, that it doesn't share the space. So its space is the left-hand side, which is this side right here, and the right-hand side, which is this side. It will not share that space with any other variable or number. So what we're going to do is we want to find out what we need to do to make sure that x stands alone on one side of the equation. Okay, Anastasia, correct. Thank you. Thank you for responding. So what we're going to do now is we're going to find a way to isolate x. We have 5x on the left hand side, we have 3x on the right hand side. So we're going to bring all the x's together. So to do that, we're going to subtract 3x from both sides. And the reason why we're doing that is we want to make sure we get it out of this side, we get the x out of this side of the equation. So we're going to have 5x minus 3x, that is 2x, and now 3x minus 3x is 0. So you can see that we've now moved the x away from the right hand side. This is equal to 10. Now we have a situation where we have 2 units, 2 x's. So how do we get to 1? You're going to divide by 2. The other way you can look at this is I'm multiplying x by 2. So what am I going to do to get x by itself? I'm going to divide. I'm going to do the opposite. I'm going to divide it by 2. And whatever I do on the left-hand side, I must do on the right-hand side. So 2x divided by 2, I'm going to cross this out. And I have x right here. 10 divided by 2, I have 5. So this is the value of x. So we can say now that x is equal to 5. And if you want to cross-check your answer, because that's always good practice, if you have the time, especially if you've been able to save time on your test and you want to go back and review your answers, what we can do here is we say 5 multiplied, we said x is 5, 5 multiplied by 5 is equal to 3 multiplied by 5 plus 10. Let's see if this is true. 5 multiplied by 5 is 25. 3 multiplied by 5 is 15, and then we add 10 to that. So 25 is equal to 25. So this is a true statement. Therefore, our x is correct. So that's how you test, that's how you cross-check your answer. All right, so we're going to do, I think, one more problem, and then we will go ahead and do our puzzles for the day. Okay, our 5th and 6th graders, we're looking at stem and leaf plots. So the season average of the top players in a basketball league are 27.8, 24.7, 28.6, 26.4, 29.7, 22.7, 28.8, 24.9, and 31.8. So here we're going to be creating our stem and leaf plot. We're going to create a stem and leaf diagram. So we're going to create our stem and leaf diagram. So what I want you to do here is to create a stem and leaf diagram or plot for the data that we're given, and then we're going to answer a question. Last time I think I did something about range or something along those lines, so I'm going to ask you something that is a bit different today. We want to find out how many players had scored at least 28.0 points for the season. How many players had scored at least 28.0 points for the season? So to do that, you have to first create your stem and leaf plot. And how would you do that? There is a method that makes a lot of sense to me, and that is you would first organize or order all your numbers from the least to the greatest, so from the smallest number to the largest number. So you have to go ahead and do that first before you can proceed. It's actually the best way to do it. Okay, so Simi has answered. So let's go ahead and try to create our stem and leaf plot. Let's look at our smallest number. Let's say that is 22.7, I think. So we got 22.7, 22.7. The next number, let's see, is there a 23? No, there's a 24. So we have 24.7, 24.7. Let's see, is there any other 24? Yes, we do have one. So it's 24.9. And I will show you shortly what a stem and leaf plot is. Thanks for asking the question. So we have 24.9. So do we have a 25? No, we have 26. So we come here. This is 26.4. And then do we have a 27? Yes, we have one. So we have 27.8. Okay, let's cancel that out. We have a 28.6. We have a 28.8. 28.8. Sorry, 28.8. We have a 29.7 and then a 31.8. 29.7 and a 31.8. So now we're going to come up with our rule for the stem and leaf plot. The easiest thing I can come up with here is to say that every number to the left of the decimal point is our stem and every number to the right is our leaf. So we're going to create a table here, and I hope I can draw this straight. So we have stem here, and then we have our leaf right here. So what we're going to do now is look for every unique number to the left of the decimal. So what we're looking for here are these numbers right here: 22, 24, 26, 27, 28, 29, and 31. So these are going to be our stems. So our stems here would be we have 22, then we have 24. So it doesn't matter how many times you see the stem appear, you're only going to represent it once, and the leaf will show us how many leaves there are. So I'll show you exactly what that means. Now we have 26, we have 27, we have 28, we have 29, and then we have 31. So these are different stems that we have. Now let's focus on the leaves. The leaves are going to be the numbers after the decimal. So I'm going to use red here so we can see them clearly. So 22, we just have a leaf, which is 7. There's no other 22, so we move on. 24, we have 7 and 9. So this is 7 and 9. So that's going to be the leaf for 24. We have 7 and 9. For 26, we have just 4. For 27, we have just 8. 28, we have 6 and 8. 29, we have just 7. And then 31, we have 8. So that is the first part of the question. The next part is we want to find out how many players scored at least 28.0 points. So anything above 28. You can simply do that here. 1, 2, 3, 4. So you all are correct, choosing 4. So that's right here. The other way you can look at that is, let's look for 28.0 on the graph. We don't have a 28.0, so we're just going to focus right about here. We're going to count how many leaves we have. We have 1, 2, 3, 4. So they're going to be 4 players because there are 4 leaves that have 28.0 and above. So that's simply what you will do in this case. So this is common in 5th grade, also 6th grade for sure. You're going to see this a lot in 6th grade. It actually goes into a little bit more detail when you get into 6th grade. So thank you for your responses on this question. And let's see, do we have time for, let's actually go to our quiz, our puzzles for the day. I try to make them a little bit, they shouldn't be difficult. They're similar to the last one. I just changed it a bit to see how you guys are going to think through these problems. So let's go ahead and proceed with our quizzes, our puzzles for the day. I have another problem, but I think we can move it to next week. Okay, so this is our puzzle. If you were here last week, you will see that it's similar, but I changed the way you are going to think about it. Okay, so this is what we have. We have two multiplied by 3 multiplied by 1 is 8. 3 multiplied by 5 multiplied by 3 is 24. 6 multiplied by 2 multiplied by 5 is 42. 3 multiplied by 8 multiplied by 3 is 33. So what is 7 multiplied by 4 multiplied by 6? What is 7 multiplied by 4 multiplied by 6? I'll wait on some of your answers. I'll give you some time to think through this. This requires some thinking. $66, okay, good try. I like to see how you got to 66. How did you get to 66? I'll wait for 1 or 2 more entries, and I'll give you a hint and see if you guys can, for those who are not able to answer it at that point, I'll see if you can figure something out. Seven plus 4 times 6. Well, okay, I can see that. I hope that worked for every other question up there, every other row, because it has to work for every single row. Let me give you a hint, since I noticed that only one person has responded. Here's a hint right here. So this should be enough. This should be a good enough hint for you to see where we're going with this problem. Does this give you a different look at the question? All right, so let me just give you a final hint here. We're going to be adding each of these right here. And we're going to, okay, we're going to add the numbers in the parentheses and multiply by the number outside the parentheses. That's the hint. So 3 plus 1 is 4, 2 multiplied by 4 is 8, 5 plus 3 is 8, 3 multiplied by 8 is 24, 2 plus 5 is 7, 7 multiplied by 6 is 42, 8 plus 3 is 11, 11 multiplied by 3 is 33. And so you now have 4 plus 6 is 10, 7 multiplied by 10 is 70. Just something for you to think about. And then we have, all right, good try. Good attempt at the dial. And we have one final puzzle, and then we shall be good for today, or for this week. So we're looking for the missing number here. 1, 3, 7, 15, 31. We have a missing number, and then 127. 1, 3, 7, 15, 31, missing number, and then 127. Let's wait for 1 or 2 responses, and then we'll be able to conclude the session for today. Wow, that's good, Dio. That's good. Good response. That's good. Jenny, take a look at it again. Take a look at it again. You're really close. All right, Simi, that is good. That is good. So you all have done a good job. You've done a good job. You've done well. Thank you for your participation. So we're going to find out the difference here. We got 2 here. We got 4 here. We have 8 here. You can see I'm multiplying by 2 every time here. We have 16 here. I'm multiplying by 2 as well. So if I multiply 16 by 2, I should have 32. So 31 plus 32 is going to give you, good job, Jaden, 63. So this is 63, and then we should have 64 here. 63 plus 64 is going to be 127. So that is our sequence for today. So that's all we have. That's all I have for today. I want to thank you all for attending the session. I really appreciate your time. I've had a really good time today, and please go ahead and subscribe to the channel. Anytime I come through questions that you guys bring up, if I notice that we don't have a video about it I'm going to go ahead and make one video for you guys. And I want you to also know that you can look at the playlist on our channel. We have several playlists. Regardless of your grade, there should be something for you. There's a playlist for decimals, so you can see a whole lot more. You can see a lot more examples on converting from fractions to decimals. I have playlists on equations. There are lots of different playlists, and so feel free. Let your friends know that this resource is available to them. Please subscribe, share with your friends, and share with as many people as you come across. And I look forward to hanging out again with you next week. There will be a class, there will be a free session again on Thursday for 8th to 12th graders and some college students. If you have any older siblings, encourage them to join, and let us have a good time this week. So be blessed and have a wonderful week. Thank you for joining again. Oh, that's good. That's good. Thank you, Adedayo. Thank you for joining us today. I know it was your first time, probably. Thank you for joining, and I look forward to seeing you again next week. All right. Bye for now.